Adding vectors along the same plane. So first of all, a couple of definitions. A vector is a quantity that has magnitude as well as direction. We've used it with displacement, velocity, acceleration, and a new quantity that we'll soon see, force. A scalar, on the other hand, is a quantity that has magnitude only, such as temperature, mass, time, and speed. With vectors, we can represent them by an arrow, and that arrow should be drawn to scale, and the direction represents its quantity. The magnitude, for example, I made this a scale of 1 centimeter equals 1 meter per second squared. You can see the 5 meters per second arrow is half as long as the 10 meters per second arrow. They're both pointing in the same direction. To show opposite directions, just draw it the other direction. And you can also use negatives when you're working with it, or directions such as east and west. Let's add some vectors. In our first example, Emily walks 15 kilometers east one day and then turns around and walks 20 kilometers east the next day. She doesn't turn around, she goes the same direction. We want to find her total displacement. So here's Emily's displacement the first day to the east. There's her displacement the second day, and you just add them together. And if we were drawing it and doing it graphically, we would have an arrow to represent 35 kilometers. Mathematically, they're in the same direction, so they're both positive quantities, and her displacement is 35 kilometers east. We call that the net displacement as well as the resultant. You can use either of those terms. In our second example, Emily walks 10 kilometers west one day, and then she heads 14 kilometers east the next. Find her displacement. She walks 10 kilometers west one day. The next day, she turns around and walks 14 kilometers east. Her net displacement is 4 kilometers. So we can see this graphically. Mathematically, we usually used east and north as positive values, west and south as negative values. So adding these vectors, I have negative 10 kilometers plus 14 kilometers will give us a net displacement of 4 kilometers to the east.